So you've configured a GRE tunnel, but is it stable? Let's have a look at a few things that can go wrong, and then follow up with a few ways to make your tunnel bulletproof. We may start with static routing, but you probably want to use a routing protocol. That's great, but if we're not careful, we can cause serious problems. Take this topology as an example. We've got the static route in place, so edge 1 can reach edge 2 and build a tunnel. When we add OSPF, we're peering across the tunnel, and each /24 network is advertised dynamically. Can you see the problem with the scenario? Firstly, remember that GRE traffic is encapsulated and sent across the underlay. Edge 1 has now received a route to 10.20.20.0 over the tunnel. This is a /24 network, which is a longer match than the /16 static route. Now, edge 1 will try to route GRE encapsulated traffic across the tunnel, not the underlay. This cannot possibly work. Now that tunnel traffic cannot reach the edge 2 router, the tunnel goes down. This puts us in an interesting state. When the tunnel goes down, so does OSPF. Now, these /24 routes are no longer in the routing table, so the /16 is relevant again. Traffic then flows over the underlay and the tunnel comes back up. So does OSPF, and the whole process repeats again and again and again. We call this recursive routing. Let me quickly show you what this would look like on a real router. We're connected to the console port of edge 1 and edge 2. On edge 2, we advertise 10.20.20/24 into OSPF. It doesn't take long before we see problems with the tunnel. The router detects recursive routing and brings the tunnel down. OSPF is notified, and the neighbor is brought down too. Edge 2 doesn't see the problem straight away. Rather, it needs to wait for the dead timer to expire and bring the OSPF relationship down. Now traffic flows across the underlay, and the tunnel and OSPF will repair. This, of course, causes the whole process to repeat. So, as I said earlier, this is called recursive routing, and can happen when the underlay routes leak into the tunnel. As we just saw, this can happen due to LPM. Regardless of other factors, longest match always wins. It can also happen if the route over the tunnel has a better metric. Think of RIP for example. Its metric is based around hop count. The tunnel certainly has a better hop count than the underlay. A less likely case is when the tunnel uses a routing protocol with a lower administrative distance than the underlay. How do we prevent this from happening? One approach is to use different routing protocols for an overlay and an underlay. This enables routing separation. It's now a lot harder to advertise the underlay routes into the overlay. Another option again is to create a static host route for the underlay. This is a bit manual, but it has the lowest administrative distance, and it's impossible to get a longer match. Well, the tricky one's out of the way, so let's look at something a little bit lighter. Sometimes there are multiple paths between two routers. If we have this case, we should try to use it to our advantage. When configuring the tunnel interface, however, it's common to use the source and destination IPs of the physical interfaces. The problem with this is now the tunnel is tied to those interfaces. If that path goes down, the tunnel goes down too. An alternative is to create a loopback interface at either end and configure routing so that they can reach each other. Now you can use these as your tunnel source and destination. If one of these paths fails, the tunnel will automatically use the other path. And while we're talking about interfaces, did you know that the tunnel source can be either an IP address or an interface name? So what's the difference? When an interface name is used, the tunnel interface is tied to the state of the physical interface. So that means that if the physical interface goes down, the tunnel will go down as well. If an IP address is used as a source, the tunnel is independent of the interface. So if the physical interface goes down, the tunnel will not, it will stay up. On the surface, the IP address sounds like a better option. After all, the tunnel does stay up, right? Well, no, it is not better. Traffic will still try to pass over the tunnel, even if it's not working. The traffic then goes into a black hole. If you're using a routing protocol, it will eventually discover that the tunnel is down, but that requires waiting for timers to expire, so it can take a bit longer. So, if we use the interface name as a source, and the interface goes down, the local router will notice and bring the tunnel down too. The remote router, on the other hand, will not notice any problem immediately. This is because, unlike physical links, tunnels are stateless. They are unaware of the state of the path that they're taking. We can also see this if a link along the path fails. In this case, neither router will actually notice and the tunnel will stay up. The solution here is to use Keepalives. Configuring Keepalives causes the router to send heartbeats across the tunnel, verifying that the tunnel is up. If enough Keepalives go missing, the router will consider the tunnel to be down. And now for the catch. It's really sad, but Keepalives do not work on GRE tunnels that are encrypted with IPSec. So, if you're in that case, you're going to need to find another option. And before you say, BFD, that's the best option, sorry, it also won't work with IPSec. So, one option is to configure IPSec with crypto maps, rather than adding encryption to the tunnel in the way we discussed in the last video. This is a design change for you though, as this is policy-based and not route-based, which means you can't use dynamic routing. The other option is to use a dynamic routing protocol instead of static routes. If you're doing this, you'll need to tune your timers right down so that they can notice a failure really quickly and respond accordingly. And the final option is to configure IP SLA and use it to trigger a script that takes down the interface whenever a fault is found. I'll include a link to a site with an example of this in the description. If you know of any other alternatives that I haven't come across yet, please share them in the comments. I'd love to hear about them. Now, if you're looking to go deeper, perhaps for a CCIE exam, there's a fantastic article on the Cisco Learning Network called Anatomy of GRE Tunnels. I highly recommend this, and I'll include a link to that as well. If you've enjoyed this series, please subscribe. There's more cool stuff on the way.